Hey everyone, and welcome back to Knowledge on Ears. Here we have a soil moisture meter, and we're sticking it into the right side of our pot. It says that it's moist, which means it has a good amount of water. If we stick it into the other side just to check, it also says that it has a good amount of water, so our plant is doing good. Now we're going to go into the more detail into a soil moisture meter. Let's learn more. Hey everyone, and welcome back to Knowledge on Ears. Today, we're going to be talking about what soil moisture meters are and how they work. We already just looked at a quick demonstration of how to use it and what it does, but now let's just dive straight into the theory. This is a soil moisture meter, and it's really just a meter with some probe attached to it. And you stick this probe into the soil, and it tells you how much moisture there is in the soil. There's a meter reading over here, and it's between 1 to 10, and it tells you if it's dry, moist, or wet. So, why do we use a moisture meter though? Well, obviously, we use it for plants. It's very important for plants because it's important to know if we overwater or underwater our plants. Me personally, I overwater my plants all the time, so I need this moisture meter to tell me the condition of my plants. But on this moisture meter, do you even see a battery attached to it? Without a battery, how does it work? How does this arrow point anywhere? How does it even control the arrow? What's going on? Well, before we understand this, we're just going to quickly try to understand what a battery is, and then we'll come back to this. So, this picture right here is the traditional picture of a battery. There's three main parts. 2 electrodes and an electrolyte. So electrodes, these two, is anode and cathode. And what they are is that they're two different conductive materials. Like often you'll see zinc and copper, you'll see aluminum and copper. So they're two different conductive materials. And we have an anode here, which is a positive terminal, and cathode, negative. The anode loses electrons and goes through the circuit, and the cathode gains these electrons. There's also an electrolyte here, which is like the main chemical part of the cell. It's where the chemical reactions happen, and it can be like a gel, it can be a liquid, it can be a paste, it just depends. And what they do is they allow ions to actually flow through, and they allow chemical reactions to happen. They do the main thing of the battery. So they have to be conductive, remember that. These electrolytes have to be conductive, because we're going to come back to that soon. So, in a battery, there's two main processes, oxidation and reduction. And oxidation, basically what it is when the anode loses electrons. And reduction is when the electrons are gained. So that's, in simple terms, that's what it is. And oxidation and reduction is what drives the cell. It's what creates a voltage between a potential difference, and current starts flowing. It drives the whole thing. So, over here, we said earlier that there's no battery. But is there? Because right here, there's actually a battery, an invisible battery. And it's the same thing as this whole thing. It's the exact same. So these two parts are two dissimilar metals. They're different metals. And I think it's zinc and copper. And when you just stick this into the soil moisture is the electrolyte. So it reacts with these two different electrodes, the zinc and copper. And it practically works the same way as what we just discussed. So there's oxidation or reduction, there's reactions, and voltage is created and current flows. So a battery is created. But wait, what determines how much current is created or produced? Well, we just said earlier that electrolytes have to be conductive. So now, if we look at water, if we look in the term of moisture, if there is more moisture, then that means more conductivity. It's just simple like that. That's the rule. More moisture, then more conductivity. So, if there's more conductivity, so let's just write that down. Moisture increases, then the conductivity will always increase of the electrolyte. And then if conductivity increases, then the whole process of the battery becomes stronger, the current becomes stronger, right? So if conductivity increases, that means the electrolyte becomes stronger, and the current starts to increase. So the formula is, if we look at this, then if moisture increases, current will always increase. So in a plant, in a soil pot, if there's more moisture, then there's more current being produced by this little invisible battery. So that's how this works. What happens is that we have this current is created, and if there's more moisture in the soil, more current is created. But how does this meter detect that? Well, this meter has this system, internal system inside, which reads how much current was produced, and if more current is produced, then the meter has this system where that understands this. So more current, then it'll know there's more current, and then the reading will go higher. So more current technically means there's more moisture, and it'll go higher on the scale. But how does this meter system even work? Like, what's inside here? Well, I haven't actually opened it before, and I don't exactly know what's inside, but I can make a good guess because it seems very similar to an ammeter. Why? Because both of them read current. Ammeter reads how much current there is, and this moisture meter also reads how much current it is and knows how much moisture there is by that. And ammeters, how they typically work is that there's current that passes through some type of coil. And we know from the basic laws of electromagnetism that when there's current passing, magnetic fields are created. So if there's more current passing, then a greater magnetic field gets created, right? And we have over here this needle pointer, just like the scale, the reading that we have on our moisture detector. So if there's a greater magnetic field, it pushes this needle pointer farther, and then a higher ammeter reading, a higher current reading is found. So I think it works very similarly to an ammeter, and it sees that if there's more current, then a greater magnetic field, and it's higher on this moisture reading. But I'm not totally sure how the inside works. So it might be like an analog ammeter. So the pros of a moisture meter is that, well, it's battery free. We don't have to spend cells. We don't have to have batteries put into here because it has its own battery. We don't have to always change your battery again and again because this battery works forever. So thank you for listening. I hope you enjoyed learning about this moisture meter, soil moisture meter, and I hope it really helped. Thank you. See you all later. Bye.